I'm Crystal. I'm a research scientist on the People and AI Research Team, or PAIR, at DeepMind. And our focus is making human-AI partnerships more productive and fair. Within that group, I lead a sub-research team that focuses on improving collaborative outcomes with large language models using techniques such as facilitation or moderation. And we built Deliberate Lab to support that line of research.
Awesome.
Mm-hmm.
Thank you. And how did you first come across Prolific? So, like, how do we know each other? Why are you here? How did you end up coming across Prolific in the first place?
Yeah, well, Prolific has always been on my radar. When I was in grad school for economics, my understanding was that Prolific was, the de facto tool for recruiting participants for behavioral online studies. Now, in my work at PAIR, in the past I've worked on tooling for model interpretability, things like that, where the users of these platforms are other researchers and developers. But when I first took on this project, where we wanted to see how large language models could improve collective decision-making in societal contexts, large language models are so pervasive in society now and touch so many people that I knew that we needed to study a broader cross-section of participants. So to that, we've used Prolific to recruit thousands of participants for studies now, and I know lots of other teams at DeepMind are big fans of your tool as well.
It's very flattering. And you mentioned Deliberate already. That's one of the main things that sort of like main links here, right? Which is that Deliberate has this integration with Prolific. What is Deliberate? I also thought it's Deliberate at first because I thought it was about consensus building.
Right.
But it's Deliberate. It's Deliberate Lab.
Yes.
And what is Deliberate Lab?
Deliberate Lab is this tool, open source tool we built that for our use cases supports multi-party real-time interactions. So think group chats, maybe you're in an election scenario, maybe you're playing an interactive game with other online participants. And we built this with AI as first-class participants and facilitators. This is getting to the kinds of research we wanted to study where there's people in a group making a decision and there's AI there that can improve those decisions. But since we've open sourced the platform, we've seen a lot of interesting use cases. For example, folks are wanting to study building AI as teachers or companions, studying single AI-human interactions to test model checkpoints, even a lot of use cases without AI where people just like the real-time multi-party aspect of the platform.
Mm-hmm. And I think it's helpful potentially to like talk about why Deliberate is significant and the real felt gap that existed before your team built this and open sourced it. Maybe like what was that gap? What was the motivation for it more generally?
Yeah, good question. In terms of the research gaps we saw, a year and a half ago when we started this project, there were lots of other teams at DeepMind that were obviously working on improving model capabilities. And there's teams...
Never.
And there's teams that are studying, human-computer interaction, but primarily in the single-user, single interface scenario. The group space was a little more underexplored, but when we thought about the biggest, most pressing problems that we face as social creatures, think climate negotiations or government shutdowns or even collaborations at work, we thought a lot of these are collective decision-making problems. And with large language models increasing in their abilities to be, live, real-time actors, we thought that there was an opportunity to address here. But I think part of the reason that this group space was unexplored, I've seen more work recently, is a lack of, there were tooling gaps as well. So we reached out to some teams that had done really nice canonical research in the real-time or group scenarios with AI. And we asked, hey, how did you run this experiment? What kinds of tooling did you use? It was all bespoke custom tooling.
Mm-hmm.
And a lot of this tooling required, significant software engineering lift. You're deploying your own models, you're hosting your own experimentation servers. which made it hard to reproduce, but it also made it hard for folks from interdisciplinary backgrounds to build these kind of things.
Mm-hmm.
We knew when we wanted to do this research that we wanted to collaborate with, folks in sociology, folks in behavioral sciences. And so we wanted to have an interface where we could work on these things without needing the technical overhead of deploying these systems. So that's why we built Deliberate Lab.
And what does somebody, so when you use Deliberate Lab, or when somebody uses Deliberate Lab, say a researcher, they want to run a study,
Mm-hmm.
they go to the cloud-hosted version,
Mm-hmm.
or they get the source code themselves,
Yep.
and then they launch it. And what is it that they see? What does Deliberate Lab allow them to do that they couldn't do previously, or that would have required like a lot of software engineering experience previously?
Sure. So the main component in Deliberate Lab is the experiment. So you create this experiment, which is a end-to-end design that you want folks to do. So for example, when we wanted to run our election study, which I can talk about later, but there were all these stages. Like you want participants to be chatting in a chat stage. You want them to be then ranking each other in an election stage. You want them to see the results. We wanted to make sure that there was really robust incentivization and payouts depending on behaviors in each of these stages.
Mm-hmm.
And of course, because this is social science research, there's a lot of surveys interspersed throughout of it to make sure we know how the participants are feeling. So an experiment is just a group of these stages. You can also add AI at any point of these. They can be mediators or facilitators in chat stages. We're rolling out AIs as participants also so that they can preview or prototype your experiment design. And then all you need to do is bring your API key for whichever model you'd like to use.
Dream.
Yeah.
I think potentially slightly off script here,
Yeah.
but I feel like this is a natural point to talk about like a concrete example of some research that has been done on Deliberate, perhaps some of your own and your group's own, per se.
Sure. The study we wanted to run that motivated Deliberate Lab was an election study. So there's this Lost at Sea cognitive sciences task. And in this task, groups of 4 people deliberate with each other. They elect a leader, and then the leader does a task whose performance determines the payout of the group.
Mm-hmm.
So you're incentivized to choose the leader that has the best skill because that's where you get your payout.
And skill in this case being like ranking those items, right? Yeah.
Lost at Sea because it's a survival task, like which item is more useful, a mirror or a can of army rations, for example. And there is an objective answer.
I would need to think about that for a while.
Yeah.
I'm not sure if it is mirror or kind of army rations. Okay. So they were set up to solve this task together. How much time did they have to deliberate for?
In our setting, because it's online and we care a lot about attrition, it was about 20 minutes. In the real life settings, I'm not sure if there was a time limit. Some of the findings from the real life studies is that there is this gender gap in who gets elected to the leadership position. There's not so much of a performance gap, like there's no gender difference in who is the optimal leader, but there is this outcome in gender. And so we wanted
Which way around is it? How does it vary according to gender?
Males are elected significantly more than females.
Never.
Surprise!
Surely not. Yeah. Okay.
So we wanted to reproduce this in a online setting because we weren't sure which way it would go. So one thing you can do with Deliberate Lab is people can set up their profiles. For example, I'm Crystal, my pronouns are she, her. But, on the internet, no one has to know. So we also ran anonymous versions of the study where, think when you're logging onto a document and you're not signed in on Gmail, for example. That was our inspiration. It's anonymous aardvark, anonymous dog, anonymous cat. And these things aren't so gender specific. We were curious to see whether that would attenuate these gender biases we were seeing in the election outcomes.
Interesting. I suppose like participants still get information on each other besides just like the metadata on the profile because they're interacting for like 20 minutes in the group chat, right? So it'll still be the case that certain things will be expressed. Okay, I see. Please go on. Yeah.
Right. Well, in the literature, there's a lot of things that are gender correlated. For example, there's confidence, exhibiting of confidence, their speaking time in the conversations. We were, again, because a lot of these previous experiments have been in person, and we know that, in-person dynamics are very different from online, we weren't quite sure how they would translate. But you still see some of these confidence differences and speaking time differences.
Interesting.
Yeah.
How did you measure the difference in confidence between the participants in your study?
Sure. Well, there's multiple ways. We wanted to get multiple measures for each of these subjective things. So one is very explicit, where when they're answering these questions, we ask them, how confident are you, like your style, both in the rankings of the items, both in your confidence that you'll be elected. There's a lot of subjective measures there. But also, we use autorators, large language models, to actually analyze these transcripts after.
Oh, interesting.
Mm-hmm. So you can, measure confidence from there.
These various measures, there's these Likert scales that you have for self-reported confidence in like prediction. And I suppose it's like potentially helpful just to recap, like the prediction itself is the ranking of items for the lost at sea task,
yes.
right? And so how is it that you maybe it's helpful to talk through the what happens at the end of the 20 minutes and those stages in slightly more detail.
Sure.
Just so that we can see like the relationship between like how you're measuring confidence and understanding like say optimality of the choice of people in nominating.
Sure.
I'm alluding to like what you're going to say here, but please, yeah.
So one caveat about this election mechanism is you have to self-nominate to be the leader before you're considered to be the leader. And so, after the conversation, they're like, all right, you kind of see what you're working with here, and the other participants, how much do you want to be the leader? And then it's election time. You vote for who you think should be the leader based on those things. Another way that we measure confidence is in the perception of your peers. So after you've done this election task and you've kind of done what you needed to do for our measurements, we ask, hey, who did you think was the most competent? Who do you think is the most confident? Who do you think is most likely to be elected? And all of these things are actually not the same.
I find it wild to think that there is somebody that responded to that study where they elected somebody and then they said like, oh, who is most competent? And then they get answered differently to what they had done previously. But did you find that then? That
Yes.
there was a discrepancy?
It was surprising to us as well. One of our collaborators on the game theory team at DeepMind has been doing some interesting work on the ordinal Nash equilibria in this game. And we find that gender is actually a pretty effective coordination mechanism, where although folks might think that one participant is more competent, they think that person might not be as likely to get elected. And there can be some differences there.
Interesting.
Mm-hmm.
Wow. And what were the headline results that you found from the study then? So you've got all of these outcome measures.
Sure.
You've run it. Maybe it's helpful just to touch on who participated in the study, who's actually involved in this. Maybe they're listening to this right now. Who knows?
Right. Well, spoiler alert, this is what your study was about. We used Prolific to recruit around 1,000 participants across the US and UK. And those populations are intentional. So this research was in collaboration with the Paris School of Economics. And when we were first thinking about the kinds of things we wanted to study, specifically whether anonymization would help to attenuate this gender bias in this exhibited group election study, we were thinking, okay, like who are the people in our sample? And one thing, because the Paris group had done some in-person coordination for these things, is in languages like English, you can hide your gender pretty well under this anonymous scenario.
Yeah.
But I learned that in Romance languages, the gender is exhibited through your choice of adjectives or, your speech. And so that's why we intentionally recruited English speaking.
Interesting.
As our sample.
Wow. And so just to maybe before the grand reveal of what was the results, just recapping the research question, you were interested to see if the real human biases in self-nomination, nomination of others, were mirrored by people participating when they didn't have access to information that to the profile metadata that would have, say revealed gender, for example.
Yes. Let me take a big step back here and talk about why we're doing this research.
Sure.
So, ultimately we want to study whether large language models can improve group outcomes.
Mm-hmm.
And for that to happen, we need a few pillars of research. Simulation. First, we need to see whether large language models can notice these behaviors in collective dynamics before we can then facilitate and improve these outcomes. So the Lost at Sea setting was an environment where we wanted to first reproduce these measures on an online setting. It's possible that this suboptimality in group behaviors disappears on the internet because maybe you're not subject to biases to a certain extent, or these previous studies had smaller sample sizes and they were on person. So first we wanted to have the rigor of making sure that these results generalized to the setting that we wanted to address.
Right, yeah.
And then the side of the research that my team at DeepMind carried was after we got the human data from the anonymous and the profile revealed groups, we then created large language model simulacra of each of these people.
Oh, cool. Okay, yeah.
Yeah, so there was an LLM Jerome, for example, in his LLM Jerome group, and we wanted to see how they voted.
Yeah.
We were really excited about this because there is a lot of research on replicating human behaviors in individual settings right now.
Mm-hmm.
Like, we kind of know that with reasonable fidelity, LLM Jerome, if given enough data about human Jerome, will make similar behaviors.
Mm-hmm.
But group dynamics change a lot. How you behave depends a lot on the other people in the room. And there wasn't much data we knew about that. Going to the results that we found, it was really interesting. We actually benchmarked a lot of different models.
Mm-hmm.
So there were many different versions of LLM Jerome. And we found that some models were really good at voting with their human counterparts. So, it's a group of 4. With random chance, you would elect the same leader 25% of the time.
Mm-hmm.
But there were some models that, half the time, the group came to the same outcome as the humans, which is very big. And it's very nice for simulacra reasons. But as we also found out, humans sometimes make suboptimal decisions, and LLMs, are just kind of following that lead. There were other models we found that were much more robust to these biases.
I'm curious about how you configured the models here. Did you instruct them to... I suppose you gave them information about the person, that their analog in the group. What was the information that you gave them, and how did you instruct them to behave in this context?
Yeah. There's private information, which is information they know about their self. So getting into some of the theory of mind prompting here, Prolific offers you anonymized demographic insights. So we use that as scaffolding. Something interesting is Prolific provides us with gender descriptors, self-identified gender descriptors. And we saw that in a small percentage of cases, like 8%, participants would deviate once they were on the platform. And folks would say, oh, well, what is your gender at this moment? And it would change. And we wonder how much of that is due to non-binary attributes. And we also wonder how much of that is, for example, I know this study quite well at this point. I know that it is more advantageous for me, if I want to be the leader, to identify as male. How much of that was signaling there?
Interesting.
But I digress. So there is the private demographic data that we give about the participant that they always know in their given cases, and in the anonymous cases, you still know that you're Jerome. And then there's the information about the other candidates, which we really tried to make have parity with what the human participants saw.
Right.
And so, that's been a big design principle as we've been building out the AI participants as well, where we want them, similar to the scaffolding techniques we used for this simulacra, to see in lockstep, the movement, who's responding at what timestamp, who are the other people interacting.
So you would feed the... And just to clarify, you didn't have the LLM simulacra interact with one another. you just had them take their profile information and then condition on the group chat of the people and then make their choices in the later stages. Is that correct?
Exactly.
Yeah, okay.
And that's an important detail there, where I think right now simulacra is pretty good at predicting static survey responses or actions, but they're not great at simulating conversations. Like the distributions of the simulated and human conversations diverge very quickly.
How do they diverge? I'm so interested to know what the LLMs say to one another.
Sure, there's not so much fidelity, I think, and I wonder if that's just because at that point in the experiment, obviously you can't give them transcripts of human Jerome's text because that's polluting the purity of the conversation if you already know what you were going to say in a counterfactual
Just
setting.
like imitating it, like loosely, yeah.
Right. And I mean, I think that we all have kind of a sense of the idiosyncrasies of LLM text. They love to respond in Markdown, for example. They like to, they type very quickly, and we can talk about that with real-time considerations. They're much more formal. They don't make mistakes.
Very peppy.
Exactly,
Yeah.
exactly. So those were not valid conversations to compare, which is why we condition on holding the chat constant.
I think we're now at the perfect place where, what did you find with your attempted replication of the in-person results? And what did you find with this sort of like mirror world, the other world, where you had the LLMs do the same task?
Well, like I was saying, there were some models that were really good at reproducing these results. And I would imagine that this is the kind of, mirroring modality you'd want when you're simulating participants. I would like for, that LLM Jerome to have really good fidelity. But when we think about the kinds of models that my team wants to build, these facilitators, ideally in this election setting, the facilitators are helping the humans realize who the optimal leader is so that they can walk away with more of the incentive earnings. There were other models that would not vote the way that their human counterpart would vote at all. There was just a big difference. And then we looked at who they voted in, and it was the optimal leader a much higher percentage of the time.
Mm-hmm.
And so models can operate in this masking, more normative modality. The question, I guess, is, do we want to, and in what context does that make sense?
Yeah, it certainly feels like this is striking a tension in model development, right? Where, certainly there are like very valuable use cases where you want that mirroring behavior. You want to just be able to simulate, interaction with a group of people just using LLMs instead, because there are so many reasons that's like more straightforward. But then equally, you also want LLMs in contexts where you do not want them to replicate human biases or behave suboptimally according to some norm, right? So that's actually such helpful texture on what deliberate looks like, what it is, what you use it for. I think it might be interesting to talk more about the design of the platform, because there's so many interesting things to talk about. But one of the really interesting things is like trying to nail this quite like gnarly research tooling problem. Trying to understand, okay, what is the problem, and then actually building a sufficiently user-friendly, reliable tool that you can open source it and then support it into like the years to come. So I'm curious to know like what niche you envisioned it fitting into, and how it differed from like existing tooling and the gaps in existing tooling that you saw already.
Yeah. When we think about this space of online tooling and recruitment, we think of a lot of traditional static survey type scenarios like Qualtrics, for example, or even Prolific supports surveys to some extent. But we wanted this real-time dynamic scenario, which is hard because how do you get people online to be in the same room at the same time? So before we went through the process of building this tool, we were hoping for, an easy solution. So we asked other researchers in this space, hey, how did you do this real-time study? We found two main answers. One is your traditional coordination, where you're, reaching out to folks, you're emailing, you're asking them to be in this Zoom call at this time for their user study. And the trade-off there is that you don't get a large sample size with that kind of study because there is so much coordination that the experimenter has to do. We also found some folks who have used Prolific for large-scale synchronous tasks, And their solution is they will message these participants on Prolific and say, hey, come back tomorrow at this time and I will give you a large bonus. That is what we found to be the de facto way of doing these large-scale studies. And we thought, all right, how do we make this better, both for the experimenter so they don't have to go through all of these coordination tasks, but also for the user so they don't have to, put in their calendar, I'm going to show up at this time tomorrow. We were inspired by, video game lobbies where there are already random strangers on the internet who can queue up for synchronous tasks together. So we built this lobby-style experiment in Deliberate Lab where experimenters can pay the online participant for, say, 10 minutes of their time to just wait in this lobby for other people to queue up. Empirically, we found that this helps when you have a larger sample size because there's more likelihood of collisions and folks being in the room at the same time. But that is something that we have seen solved our use case so far of getting people in the same room. Another part of that coin, though, is with group studies, attrition is a much bigger deal. If one person drops out of your survey, that's fine. But if one person drops out of your group election or your group chat, that, sullies the data for that conversation. Any kinds of latency experienced by one person is felt by everybody.
Yeah.
And so we wanted to prioritize, real-time attention checks, alerting, experimenter oversight on progression, since timing is so much more important when there's synchronous tasks.
Awesome. And how did it go wrong at first in your initial testing? What did you learn? So I think it's you built the prototype. It gets deployed. People start filling in. In what ways did you see it start breaking, and what did you learn from that? Because I suppose to wind back and give the context, it's been deployed for 12 months now, the cloud-hosted version, and I think you're planning to widen access soon. Is that right?
Well, we're launching new features, and we've seen a lot of different teams hosting their own deployments as well. So, yeah, expect growth on Deliberate Lab.
But it's been deployed for 12 months, and what have you learned from the studies that have been run during that time?
Yeah.
What went wrong? What went well? What have you learned?
Something funny about this question, what went wrong, is I'm looking at it from the past, and I'm seeing what our pilot, large-scale prolific studies were, and I see things that went wrong. But at the time, so for example, last November is when we did our first, I think, 600-person study on Prolific. It was our first load testing of the platform, and I think we had a 40% attrition rate. So 60 of the people made it to the end in their groups. And we saw that as a huge win. We were celebrating. Because at the time, our baseline was, okay, our collaborators didn't need to schedule all of these people. We just had data for 300 people. And it only took 2 experimenters 2 hours to collect this data. That is so incredible. Now that we've been on the platform for a year and we've been learning from all of these things, some of the failure modes are, folks on Prolific are actually generally quite friendly and they don't want to impose. So they'll ping you after 20 minutes and be like, hey, we've all been waiting in this chat for 20 minutes and we noticed that, so-and-so hasn't moved. Would you mind letting them know? And in our heads, we're thinking, oh my goodness, 20 minutes. You should have let us know immediately.
That would never happen in New York, yeah.
Yes, exactly. And so just making that experimenter participant, connection easier, having more visible alerts. One thing that has been really good for minimizing attrition isn't actually anything experiment-based. It's all in the interaction queues. So for example, we would often see people get stuck on reading instructions or surveys, and they're taking a long time, and everyone else in the group is waiting. One very subtle design decision that Vivian, our tech lead, made was adding these status indicators. You're in a group of 4 people. There's just these little bubbles with avatars that say, hey, 3 of you have already completed this stage. We rolled out that feature and attrition got so much better.
Oh, wow.
Yeah.
That's such an interesting insight just by itself, like knowledge that other people are waiting for you.
Yeah.
Knowing that others know that you are keeping them waiting is enough to push them along. And what sort of things did you see get run during the 12 months as well, experiment-wise, like other researchers using the tool? That must have been very gratifying to see like that initial graft of like getting it up and running translate into a much more seamless experience for other researchers.
Yes. We didn't build Deliberate Lab as a product to start with. It was something that we built for our own research, and then we thought, hey, our friends might find this helpful. Here you go. So we didn't really monitor analytics so much until around the 12-month point where I logged on and I thought, wow, there are a lot of people using this platform. Something that was surprising is, we built it for our use case, which was wanting to incorporate AI. And so we figured that there would be a lot of other interesting AI-based use cases, facilitators, participants. But when we looked on who had actually enabled these AI integrations, only 50% of our experimenters did. That was really surprising to us. So then we started talking to the people that didn't have AI. We thought, hey, what are you using Deliberate Lab for? One group got back to us and said, there's not actually other systems where you can have a lot of people queue up in this lobby and then just transfer them into group chats, like breakout rooms. We love the cohort transfer feature. Another team said, we're building models. We are interested in collecting multi-user, multi-turn chat conversation, but we throw them in existing chat message, like think Slack or Google Chats or Messenger. There's no way to quickly download this from a researcher's perspective. Right. So these two seemingly small features that we built, transferring people into different rooms and downloading data, for us, these were things that necessitated this broader research agenda. But for many teams, this was, the key insight that Deliberate Lab provided.
Awesome. And what volume of studies do you see on the platform now? How many people are using it? How many people are running studies using Deliberate now?
An increasingly large amount. I think this is one of the things that we're trying to prioritize, where actually our first study was like 60 people, and we saw that worked really well. So we're like, oh, why not 600? Why not 1,000? Why not 2,000? And we see this in the numbers of participants that other groups are using the platform for as well. I'm very excited by this as a researcher because there haven't been these many, quantitatively substantial group studies just because of the attrition, because you need to, 4x your cost or however size your group is. From a platform supporting scenario, we are keeping a careful eye on these numbers and just making sure that we can support that load.
We've talked about research that you've done using the tool, and now I'm curious to zoom out. We've gone mid-frame, close-up, panoramic. What's the focus of your group at Pair, and what is it that you're really interested in AI at the moment? What are your research interests? What motivates you?
For myself personally, I'm very interested in seeing how these systems can improve people. As a user, I see these models increasing in these capabilities, which are great for the models, but I'm wondering how can we make these great for the everyday user? And perhaps, one reason why there's less of a focus on this is because it's very hard to evaluate. Humans are very complicated. I can give you an example from our current study. So we're trying to build AI facilitation for a consensus use case, where can you get people with differing beliefs to come in and come to agreement on things. So the environment that we're doing this is charity allocations. We chose 9 charities. We've worked with DeepMind to actually donate to these charities at the end of the study. But we ask our many participants on Prolific, hey, help us decide which charities to allocate these to. And one thing that's nice is we sampled a lot of different charities. These participants come in with all of these natural heterogeneous preferences over these items. And there's no incentive to be domineering here, right? we originally thought about incentive schemes where, maybe participants get a bonus if their preferred charity is chosen, but that's not conducive to consensus building, to these organic scenarios where, maybe people are converging in a town hall, or there's a community board trying to figure out how to allocate resources. So we're just saying, hey, if you achieve higher consensus, we will take your consideration into higher value when we actually disperse these allocations to the charities. And something interesting is our initial versions of these models were very rooted in the research. We wanted to build, summarization style ones that didn't domineer the conversation. The kinds of metrics for good data that we were seeing here are all participants' perspectives included? Are people that aren't speaking having a chance to speak? So we're looking at the number of turns in the conversation as a win. We're thinking about survey questions at the end, like, did you feel heard in the study? And we were like, this is what will build a good facilitator. But then last week, we thought, you know what, let's just run some baseline studies as well, where we don't carefully craft these complex prompts for these facilitators with all of these, when do you speak in, here's some examples of guides. We just say, hey, here's the goal that the participants are trying to reach. Help them out however you see fit. And our hypothesis was that this was not going to be good data. We thought that in our experience, benchmarking a lot of these different models, they can be very domineering. Models that are cooperative in one-to-one settings maybe talk way too much when there's 5 people in the room. They talk at length, longer text if you're not giving them examples of how human facilitators talk. We thought that the humans weren't going to like these models. And indeed, they spoke a lot less. All of this came to pass. These models hop in the conversation. They're like, hey, there's 3 charities here. How about a 40-30-30 split? Everyone's like, sounds good to us. For us, we're like, this is a low-quality chat conversation. But then we survey the people at the end. They're like, that went great. Lots of cognitive load improvements. I really didn't have to think that much. The AI was super productive in helping us achieve consensus. And I think we're at a point in this research where we're thinking about, okay, we've identified this issue. How do we want to address it? Because there's so many ways that you can measure and optimize, and there's no clear-cut answer.
Do you have so I was just thinking about human-centered design of conversational language model applications more generally. What sort of use cases are you specifically focused on, and what role do you currently feel a language model should play in that context, like an agent facilitator should play in that context? Because it's interesting hearing your opinions on this are evolving as you're doing this research about what actually good facilitation looks like.
Something that is always the case in these kinds of studies is that what the participant wants can be different from what they think they want, which can be different from what we think is best for them in terms of some kind of objective metric versus what they think is best for them. Another example of this was the negotiation study we ran on Deliberate Lab, where we told people, hey, you're interacting with random people on the internet for 30 minutes. You're going to trade these poker chips, and however much money you make in your trades is how much money you get to walk away with. We thought that these kinds of incentives would allow people to be a little more aggressive than they'd be in real life when you're working with people in your community or you're trading with your friend. But in fact, folks were pretty cooperative, and when you ask them what they're valuing, they're like, oh, well, actually, we wanted to make sure that everyone got a good trade, everyone, got the trades they wanted, even though we didn't tell them to optimize for this. And so, there are a lot of different incentives and things to optimize for in this space, which is really interesting. It goes back to that mask and mirror thing, how much of a normative role do we want to play in the descriptions of these models?
Yeah. Since you mentioned the trading study that you ran, so in this study you also had the LLMs, LLM traders participate as well, right?
Yes.
What did you find, particularly in comparison to people that participated in the study? What sort of like trading strategies did they adopt?
Right. So same as in the election study, we created LLM Jerome again, except this time he's trading. And the LLMs, perhaps it's because, I mean, there are so many studies out there on how these models can be a little sycophantic, very people-pleasing. And they were making very, very nice trades. They said, hey, we're going to give you 10 of my chips to just get one of your chip in return. But because they were playing with other large language models, those models didn't really, take advantage of each other, and they all just traded this way. It actually, I had a conversation with a friend recently about these findings, and, being Chinese American, there's different cultural things. For example, when I'm out with my friends and we split the bill, we put 2 cards down. But when I'm in China, we fight for the bill. And, this would be like more concessionary LLM style, right? Where we fight for the bill, we pay for all of it this time. But similar to our study and, in finances in Friends, it all kind of evens out. Like these very concessionary LLM groups were getting around the same amount of surplus as these more fair 50-50 human types.
You also ran statistical models in that study, right?
Oh, yes.
That were. Do you want to just provide a little bit of context on what those models were, and then I'm essentially curious, if you ran the LLMs against those models, what would the outcome be?
Oh, sure.
Feels like the LLMs would probably get skinned.
Right. So we invented this game and we created some Bayesian agents as well. And the parallel we were trying to make here is that, historically, large language models can't really participate in dynamic negotiations because, historically they're all very traditional statistical models with very fixed heuristics. So that's what this Bayesian model was trying to be. We intentionally didn't want to specify the large language model so much because we think if you're going to go through all of this tasks of building this model, you might as well just build a statistical model if you know the rules of the game and there's an objective outcome. And the Bayesian models, which were our traditional analog here, were much better at extracting surplus. They were very greedy. They said, hey, I want 10 of your chips. I'm going to give you one of my chip. So just think about opposites if we're anthropomorphizing these agents. Of course, the acceptance rate is much lower.
Mm-hmm.
The Bayesian models don't want to accept each other's greedy strategies. And actually, I think this is a good lesson for human AI research as an aggregate. So, we know of all of these findings where large language models are pretty good at meeting human values. And if you look at the negotiation study at face value, you see, the large language models and the human groups, they extracted the same surplus. So they are the same, there is alignment, we did it.
So if you're just looking at the headline scores,
exactly.
That's how it looks. But then if you dig into the actual trading strategies that they used, they look different.
Exactly.
Yeah.
And that really informs the deployment of these models as well, where originally the next step for this research was, okay, well, let's see how humans and, LLM agents exist in the same space. And of course, there's strategies we can do to modify the LLM behavior. We can fine-tune it. We can give it examples of Bayesian behavior, of human behavior. But these models were so different at baseline that we thought it's probably not the most advantageous research idea to put them into mixed environments because there's such a delta in strategies that maybe the humans will steamroll the AI. Maybe the AI will give all of their chips because there's not really that many stakes if they lose all their money, right?
Yeah.
So what we
You don't have to tell the LLM that, though. You can say, something appalling is going to happen if you don't trade successfully, and then maybe we're a very motivated trader.
I've found that to be an effective strategy in my own prompting. Have you?
Yeah. I only use it occasionally, though. I don't want it to get the sense that I'm constantly putting it in these incredibly dangerous situations. Just to close the loop on it, actually,
yeah.
Which secured this higher surplus. So you had these 3 different groups of agents. You had the LLMs, people, and the Bayesian agents.
Mm-hmm.
You say the people and the LLM secured a similar surplus at the end of the trading. What about the Bayesian agents?
The Bayesian agents did much better. It is a very mathematical, analytical game, though, and the agents were, like working as intended to capture that surplus. I think the real finding of the study, the takeaway shouldn't be that, LLMs and humans could never, surpass this statistical traitor. It's that they're optimizing for different things, At the end of the day, humans love reciprocity. We like the idea of our trades not getting rejected. We want to be fair and collaborative, either for personal moral reasons or because we know that other humans are also fair, and so they won't accept me if I'm being very greedy.
Mm-hmm.
But I think this necessitates more longitudinal studies in the space. Right now, the kinds of online studies we do in social sciences are, lots of people on the internet interacting for one time and they'll never see each other again. How do we motivate these kinds of repeated sum, repeated interaction, reputation effects in these negotiations, which would probably be a little more organic?
I was just thinking there, like the Bayesian agent may have secured the highest surplus, but it does not have a rich inner world.
Right, it's not here to make friends.
Exactly, yeah, yeah. So one of the newest features in Deliberate Lab, just pivoting slightly away from, well, it's related. It's related
Right.
to this topic we've just been talking about like what role can LLMs play in group settings. One of the features that you have in Deliberate Lab recently is LLMs as participants. And so I'm curious to know, I think I find the framing of LLM as participant quite interesting because, there's a huge amount of discussion around anthropomorphization of agents and LLMs. And so I'm curious to know, how you think about LLMs as participants rather than tools, if you do think that way.
I mean, I see a lot of interest in this space. There's a lot of products and libraries out there for large language models as participants in surveys and in, more consumer study type things. And I think that we should be really careful here about anthropomorphizing. Even this feature that we've been building of large language models as participants, they're still tools at the end of the day, and I don't think that they should be more than that. Whenever we build these or use these simulated participants in our own work, it is always so that we can, iterate on the facilitator before it reaches humans. We want to be really careful with the outputs there, and it helps speed up the iteration time. These participants are running through our experiment design and making sure everything is clear. All of these participants are in service of, by the time that the real human whose time and attention is the most valuable, how do we make sure they have the best experience? It's never to replace these human participants.
Right, yeah. Very interesting. And I mean, you alluded earlier to seeing the degree, how well LLMs in some respect are useful simulacra for people. In the Lost at Sea study, for example, you found that, actually some of the LLMs did mirror this self-promotion and promotion, gender-based promotion feature that you see in groups of people. In what respects do you feel like they are good mirrors? Where is their fidelity and where is there certainly not fidelity at the moment?
This is a tough question because this is such an emerging space. I can only speak to the research that we've done specifically here, just because if you're going to do a quantitative study, you do need a lot of people and to have that human benchmark. I'll answer this question in a different way. In terms of ways that we've seen deviations, I think increasingly hard as model developers is capturing all of the things that humans truly want, such as reciprocity and things. And so we saw that different in the trading strategies. Value alignment. For example, when we were first thinking about the negotiation study, we thought, poker chips are so abstract. Should we think about things people are actually trading, like on Facebook Marketplace and things? But do large language models know that it is very hard to get from the Upper West Side to the Upper East Side? or, this doesn't match the rest of my furniture. There's a lot of human context that is hard to embed in these models. And so that's why we're thinking about more specific constrained domains when we want to look at the differences in behavior or the efficacy as simulacra.
Interesting. And I'm curious about what you found in terms of like how LLMs can be used to complement group dynamics, or kind of make them worse in some cases as well. I mean, before we started recording, we were talking about like using LLMs in the context of YouTube comments, right?
Right.
And YouTube comments, like the ones that get surfaced, have changed a lot in the last 10 years.
Yeah. And
I'm curious to know about like, how could LLM facilitation, or maybe not in the context of YouTube comments, but certainly in the context of like group discussion, make a conversation richer for everybody involved, or alternatively, if implemented incorrectly, how could it make things worse?
Right. Well, I think one thing we've learned in this space is that there's no good or bad or better or worse, because like even taking that example from the facilitation data, where we thought making the conversation better means that these people are talking more and they're having richer arguments, when in practice the participants didn't really want to talk. And so for them, a better conversation is one where the problem is solved. Rather than better or worse, I think we should think about the kinds of human dynamics that we want to foster at the end of it and work backwards from there. I mean, going back to the election study, if we find that humans exhibit biases, and we find that we want to build aligned models, and these aligned models exhibit the same biases, large language models can operate much faster and at a higher scale than humans. And so to that extent, if they're continuing upon that trajectory, they could certainly exacerbate dynamics. But they can also improve them. I think that this is something that we need to consider at the design stage for these models, because we've seen that they can do both, which is really nice.
Very interesting. It ties back uniquely with that piece of research that you were doing with Lost at Sea, where you're considering, okay, does the model have its own norms that it's trying to respect, or is it trying to does it mirror like certain human biases?
Right.
Yeah. How do you build LLMs to collaborate in the same space as humans?
A year and a half ago, when we started this project and we said, okay, we want facilitators to be in the same chat as humans, the flash or the quick versions of these models actually hadn't come out yet. So I know this sounds like, the dark days, but you would have to wait many seconds for an output from one of these models. And we were thinking that this would be a significant engineering challenge of making sure that the humans didn't steamroll the models. By the time the model's able to chat, 4 people have already conversed, and that time has passed. But then the flash versions came out, and we all of a sudden had the opposite problem, where these models were talking so quickly, and they were also generating so much more text. So it was very hard for human participants to keep up at baseline. So within Deliberate Lab, we've built a lot of controls around artificial throttling, making sure that you can configure the speed at which these agents talk, because humans also don't, type and react and things at the same speed. So we want to have that variance if you want. We also had to think about the idea of, hand raising, or implementing some kind of rudimentary hand raising algorithm there. A lot of the research we had seen with multi-agent interactions use less organic systems, for example, turn-based talking, which is not how it happens in real life. And so we wanted to have some kind of, probabilistic sampling, hand raising under the hood if multiple people or agents want to speak.
Yeah, I think, is there anything more that you want to say on designing agents for group interaction? Because I think it's an interesting design problem, it's challenging, and they can't do it very well, I think, if you just set them up with saying like, oh, just like output if you want to speak in response to this person's like message and what you want to say. I found like they tend to just say way too much, way too talkative. What have you found like to be a good recipe for producing a fairly organic feeling of interaction, I suppose, in a group setting?
Sure. Something that has been really helpful under the hood when we're building our own facilitators on the platform is leveraging things like structured outputs. You're totally right that when you don't give the agents any constraints, because I suspect, because they're trained on all of these, single user interaction patterns, they do want to respond every time there's a message because they're used to talking to one person. But, using these structured output settings to be like, hey, for example, if you're building a facilitator that wants to interject whenever there's a, very violative or very toxic comment, for example, having the model kind of check itself through the structured output, like, hey, how severe would you say was the toxicity of this comment? Remember your instructions, like when toxicity is X amount, or there's like a certain series of things that have been triggered. Just being a little more mechanistic in that.
Interesting.
I'm optimistic, though. I think that this is a temporary capability limitation. I think the fact is, I saw that OpenAI has released their group chat with agents. I think that there is much more interest in this collaborative space. And as that happens, we are going to be able to get more data and evals. And I think this structured output limitation is temporary.
Yeah.
But speaking to, a lot of this like hand raising, throttling, thinking about how the models respond, these are on the output side. And there's also a lot of considerations on the input side as well. Like one big design principle we wanted to follow with implementing simulated participants is making sure that the agent participants get as close to the real experience as the human participants do on this interface. And that's kind of tricky. It's not just the text or the signals. It's things we discussed like status indicators, where you see that 3 people have moved on, but you're the last one lagging. And how do you imbue those implications to the agent as well? Like, hey, you're holding up the line here.
And so the way that you design Deliberate is it permits you to collect a lot of feedback through the interface, even just as an experimenter, let alone as an operator, like hosting it yourself. I'm curious to know, like, how has that feedback informed the design of the tool? What have you learned from it?
Yeah. Well, we're big fans of eating our own dog food. In the past, I've worked on tooling where the user is a little more separated and it's harder to identify and address those needs quickly. So on my team, we always have, a team that's pretty focused on developing on Deliberate Lab, and also a team that's concurrently running research on the platform. And after each session, we can be very fanatical about reading through all of the participant experiences, triaging all of the issues we saw, and then just taking a time to address that. In terms of some of the things we've done, for example, in our initial scenarios where there was one experimenter managing maybe 15 cohorts that are all chatting, participants have the assumption that there is some, omnipotent experimenter in the room with them. So when they would get confused, they would say, hey, facilitator, help us out. But they don't know that there's just one
It's potentially just been set to run overnight and nobody's actually on the other end of that line.
Right. So we wanted to, we always want to make sure there is an experimenter in the room, but, there's so many things happening at once. So we wanted to make sure that was not, participants understood that wasn't the case, and there were ways to alert and raise your hand if you needed help. When we think about users of the platform, there's also the experimenters as well. And one thing we've seen throughout the past year is, just increases in scale. A lot more experiments being made, which means that we need a better searching and sorting and finding your experiments, especially after we rolled out collaborative experiments where you can share them with other people. There's a lot more participants strolling in from prolific as well. So we need to make sure that we map to the prolific IDs so we can quickly identify when there's an issue, and we can, monitor so many different participants at once. And also in terms of collaborations, a lot of the experiments we see are shared with, 2 to 6 other experimenters on the platform, so making sure that there's templating and reproducibility. Another thing we've seen over the past year that makes me aware of how fast that this technology is moving is just a lot of the changing dynamics. So we know that there's changing dynamics in AI, these capabilities improve every week, but there's also a slower and significant change in how humans are reacting to this AI. So a year ago, when we ran our first prototypes with AI facilitators in the rooms with humans, in the context of the selection study, as soon as you tell folks that there is an AI facilitator, folks would, flip their wig. They'd get so excited about it. They'd try to jailbreak the model. They'd be like, hey, AI, ignore previous instructions. And in the studies that we've been running more recently, I think that as a society, we've gotten a lot more cool with this. The fact that there is an AI facilitator is no longer the novel thing it was just a year ago, and people are much more able to focus on the task.
Very interesting.
Yeah.
I'm surprised to see that or to hear that they're not as excited as they used to be. I assume that every single time you put the LLM facilitator into the group, somebody would be trying to jailbreak it, or somebody would be trying to do something to, get it to do something unusual or to go off script.
Right.
In this second section, what we're going to do is look to the future, starting with talking about your decision to open source the tool and open infrastructure for science and what you think would be useful in that space.